So today we're going to do section 7.3 in Algebra 2, and that's when we're going to start introducing the number e. The number e is they call it the natural base. We're going to learn about natural logs in a few days and do logarithms tomorrow probably. And e is just a base for exponents, and it's a fancy number. It was named after a famous mathematician called Euler. It's like German and it's spelled Euler, but I think it's pronounced Euler. And so that's why it's called E, because it was named after him. He came up with this number. And it's just a base, an exponent base. So we're going to start with doing some simplifying with E. So we're basically just going to use our exponent rules. They all have a base of E. And if we multiply two things with the same base, what do we do with the exponents? We add them together. So e squared times e to the 5th power is just e to the 7th power. And that's all you do. Okay? If they want us to approximate it, this is the simplified answer. It's the exact answer. If we want to approximate that answer, we would do e to the 7th power in our calculator. But they want exact answers on these, so we're going to just leave it e to the 7th. We'll do some approximations in a little while. Let's do another one. 12e to the 4th power divided by 3e to the 3rd power. And we're just going to simplify that. Now, if we have a fraction with variables and bases and stuff in it, what's happening when we have fractions? They're being what? What mathematical operation? They're being divided, right? When I say a fraction, I'm dividing the two numbers. And then since we're dividing, if they have the same base, then we subtract the exponents. That's exactly what y'all meant. Good job. So what is 12 divided by 3? 4. So you divide the numbers. And for the e's, they're just a base. You subtract the exponent. And what is 4 minus 3? 4, it's just 1, right? So it's e to the 1st power. So you can just leave it 4e. So it's 4 times that 2.71 number. But just leave it 4e because that's the exact answer. All right, let's see another one with exponent rules. Let's say we have parentheses 5e to the negative 3x all squared. Now back from exponent rules, do y'all remember what we're supposed to do when we have everything in a parentheses with an exponent on the outside? You give everything the exponent. Okay? So even that 5 over here gets the exponent, and the e is going to get the exponent. So that's going to be 5 squared times e to that, and since it already has an exponent, I multiply it. Negative 6x, right? Negative 3x times 2 is negative 6x. Don't let it bother you that there's an x there. And y'all, what do we do with negative exponents, though? Move it to the other part of the fraction. The 5 squared is going to stay in a numerator, though, because it doesn't have a negative exponent. So we're going to do 5 squared on top. But what is 5 squared? So 25 goes on top, and we're going to bring an e to the 6x to the bottom. And when you bring it to the other part of the fraction, remember you take the negative off. And that cannot simplify anymore because there's no other bases that are the same. So there's our answer to that one. So the part that had positive exponents stays on top. Negative exponents goes to the bottom. Let's do one more with exponent properties. 2e to the negative 3 power times 6e to the 5th power. How do you think we're going to do this? Yeah, we're multiplying. That's what that dot means. So multiply the two numbers.
12e.
12. And then the e's are multiplying. So what do we do with the e's? Yeah, if they're multiplied, they both have a base of e. We add them. So what's negative 3 plus 5? 2. E squared. And everything's got a positive exponent, so that's my answer. So you multiply the numbers, add the e's. If that was a negative 2 exponent, I would put it at the bottom. Does that make sense? So that's how you simplify with ease to get exact answers. If your direction says to approximate, let me see what the book says. Yes. It'll either say approximate or use the calculator to evaluate. Then we can have rounded answers. Use calculator. So these are going to be approximate answers. Approximate means rounded. Okay? So what I want you to do is give me 4 decimal places. So we're going to practice with our calculators. And the first one we're going to do is e to the 4th power. E to the 4th power. Get out your calculator. Sorry about that. I went to the wrong thing. Turn it on. How do we get the E to show up? Y'all remember?
Second in the button.
Yes, second and then the LN button down here by the 4. So everybody do it with me so I can make sure we know how to do this because it's really easy. Mine looks like this. If you've got a fancy calculator like me and Dylan have, it will put it up there for you in the exponent. But the TI-83s do it like this with the rooftop and then a parentheses. Then in the parentheses, you type in your exponent, which is a 4. So you hit 4, close your parentheses, and hit enter, and it's going to give you a decimal. What did it tell you?
54.5.
Okay.
55.
So give me 4 decimal places. So that means you look at the 5th one to see if you need to round up or not, right?
54.598.
2. So that's y'all, this is approximately, we're rounding, so put a squiggle equals instead of an equal sign. 54.5982. Is that what we got? So look at the 5th digit to see if you need to round up or keep it the same. And do the little squiggles. Don't put equals because it's approximate. It's like pi. We're approximating when we use E. Okay? All right. Everybody okay with that one? Okay, so now let's try a negative exponent. This one is e to the negative 0.09. So how do you think we put that in? Yeah, you hit second LN. Use the little negative button down here by the enter sign. Don't use the minus button. Use the little negative at the bottom. 0.09, not 0.9, 0.09, because it won't give you the same thing. Close your parentheses and hit enter. So are we getting 0.9139? Okay, so put a squiggle equals for approximately 0.9139. I meant to write mine in red, so I'm going to change it. No, not that, just the answer. Not letting me do it. Well, darn. Be all right. All right. Let's do a fraction. E to the 3/4 power. How do you put a fraction in your calculator? The division key. Good. So hit second LN to get your E there. And then hit 3 divided by 4. 2.1170. Right? So approximately 2.1170. Is this terrible? Shouldn't be too terrible. Y'all want lots of these for homework, don't you? Y'all try this one on your own. E to the negative 5.1. Making sure we all can use our calculator fine. Give me 4 decimal places. That's right. Did y'all get 0.0061? Okay. So So any questions on how we evaluate E in our calculator? All right. So now we're going to graph these functions. Graph the function. And then we're also going to talk about the domain and range. Now, domain is what values? The x's. And range is the y. Very good. So we're going to see what's happening if we have asymptotes and all that stuff. We talked about what an asymptote was yesterday, about how we approach that line but never cross it. All right. So the first one we're going to do is we want to look at the graph of y equals 3e to the 0.25x power. It says 0.25 if you can't read my tiny writing. So write that down. Then get out your calculator. And then I want you to hit y equals, because we're going to graph this. Should not be. Everything needs to be cleared out. So I'm going to come around real quick and make sure after you hit y equals, everything is cleared out. Because if it is, so you need to clear those out. You're clear. Wait. Calculate, baby.
What? We did make it dark.
You hit second and then the up button.
Yeah.
I hope you did. This is way too easy. You know how much darker? Are you clean?
Hey, you saved the battery up there.
You done got it all done. Overachiever. Overachiever. Okay. Yeah, you can, because it darkens up the background too. All right, so we're going to type in the 3. Hit second LN to get your E there. And then I'm going to put 0.25x. Y'all remember where the X is? Where's the X? It's, beside the alpha button. It has a bunch of variables there. It'll give you the X. Close your parentheses. And look at mine and make sure yours looks like mine when you type it in. And then hit graph. The graph key is right here on the right hand side under the screen. Beside the alpha button.
You use that right there.
All right, do y'all's look like mine? Does y'all's curve look like mine? So these are exponential functions, not unlike what we graphed yesterday. So this looks very similar to an exponential growth model that we saw yesterday, correct? It's exactly what it is. It's a growth model. So what we're going to do is just tell the domain and range. So the domain is going to be what? That's our x's. What are our x's doing on this graph?
All real numbers.
They're going everywhere from left to right, so that's all real numbers. So for domain, you say all real numbers. If you write ARN, that is fine with me. All real numbers. I know what that means. If you need to know what it means, you need to spell it out. All real numbers for the domain. Now ranges means where our y's go. Do our y's ever cross the x-axis? No. So what do we say about our range? That y has to be what? Greater than what? 0. Because it looks like we have an asymptote at 0. So for the range.
So if it never crosses, does it make it go?
No, it just get what our graphs are finite. Y has to be greater than pictures out. Our graphs don't show the whole picture of the graph because obviously graphs go on forever. Okay, so but what's happening is you're getting closer and closer in like tiny little fractions, closer and closer to the point as far as you go, but you're never going to touch it. I am.
Yeah, I feel like,
Like eventually you're gonna get
like
Not on these.
9.
Not an X. It's going to have to be a really big negative, right, on that one. But to understand what infinite means, y'all, we can't wrap our human brains around it, right? Like, you can't understand infinity. I mean, to just know that numbers can get infinitely smaller and numbers can get infinitely greater, and you can never stop. Like, our brains are finite, right? We're concrete people. We like to see things to believe them, right? So, yeah. So some of mathematics is just not like that. You just have to accept it. That somebody smarter than you came up with it. Because I am not a mathematics expert. I'm a high school math expert, but I'm not. There's so much math beyond high school math that is mind blowing. And y'all might think this is mind blowing. Can you imagine what comes after this? I mean, come on. Exactly. No telling what Euler got paid to. Well, there probably wasn't a lot of money back in that day to come up with the concept of E. Yeah. Now look at this complicated thing. Check out this one. So on one like this graph, it's kind of complicated how you put it in. So go to your y equals and clear everything out of that y1. So we got to be careful with all these parentheses. So I'm going to hit second ln to get my e. Now notice it already gives me one parentheses, right? But my problem has another set of parentheses. So I have to make sure I close every set. So I'm going to say negative 0.75. And then another parentheses. And then x minus 2. I've got to close that parentheses. And then I have to close that other exponent's parentheses. So you have to have 2 open parentheses and then 2 closed parentheses. And then don't forget your plus 1. And look at mine and make sure it's typed in like mine. Where? This one you need a negative. This one you need a minus. The first one's a negative and the second one's a minus.
Yeah.
All right, now hit graph. There we go. Does y'all look like mine? If it does not, holler at me. Let me see what we're doing. It's probably just a parentheses or something.
Yes, I do.
You need to have 2 parentheses. And you use minus 2. Negative 2 is minus 2. Minus 2. Parentheses. Parentheses. All right, y'all need to be quiet. Still doing a negative 2 to a minus 2. Minus 2. Okay. You're good now. Anybody else's graph not look like mine? Everybody good? All right, so y'all tell me domain and range. What's domain?
All real numbers.
All real numbers.
So if it's on the other side of it, it'll be fake numbers. I mean, imaginary numbers.
No, those are still real numbers, but imaginary numbers exist. They just don't exist on a graph.
So why?
No.
We haven't got no.
Yeah, you won't get imaginaries on these because we're not taking square root. Say it again, Josue, so everybody can hear you.
How the domain gonna be all real numbers?
Very good. So what's our range? Do we have a y value? Oh, sorry. Where's my stuff going today? Do we have a y value that it looks like we're not going below?
Just 0 or maybe 1.
1. And if you're not sure, you can hit the trace button. And you see a little flashy thing on that arrow to the right. And your y values are popping up right here. And if you look as you go to the right, they're never going below a 1, are they?
Eventually they gonna get They gonna get close though.
See, they're getting closer and closer and closer to 1. They never crossing it. Y'all see how I did that? I hit trace and now I'm arrowing over. So it's kind of hard to see on this little bitty graph what's going on. So hit the trace button and go left and right to help do that if you need to help find your asymptote.
I'm 22 from getting to 0.
Keep going. You'll never get there.
Baby,
It'll stay above 1. It will never.
It never gets below 1. You're right.
Exactly. Y'all didn't below it. Y'all don't believe me. So what is our range then? Y has to be what? Y has to be what?
1.
Not 1. Greater than 1. Greater than 1. Does that make sense? I want y'all to try this one. And I want you to graph it in your calculator all by yourself. And I want you to tell me the domain and the range. I didn't make the graph in your calculator yesterday. No, you need help going back to where you started. Yeah. Zoom 6 gets you back to home. Zoom 6 gets you home. Zoom 6 gets you home if you've been tracing for forever.
Yeah, but it just did a staircase.
Yeah, really. I did this at home last night. No, yours is not right. Look and see if you typed it right.
Oh.
Tell me domain and range. That's right. So tell me domain and range. What the X is doing, what the Y is doing. That is right. That's right.
All real numbers.
That's right.
Yeah.
The graph's right. Y'all just tell me domain and range. Yep. All right, so what did y'all get for your domain?
All real numbers.
All real numbers. What did you get for your range? Less than 0? Does it go above 0 or below 0?
Y is greater than 0.
Yeah, so Y is greater than 0. Raise your hand if you got Y is greater than 0 for your range. All right. So the last thing we're going to talk about today is an application of using E. And it's called continuously compounded interest. I like talking about money earlier. You do need to know this formula. APERT.
E is time. R is rate.
E is what E is, right? E is a number, right?
P is what you start out with.
P is what?
What you start out with.
Yes, P means principal, which is the same thing as initial. Okay, that means the beginning. Initial. That's not, look at that. I-N-I. Is that how you spell initial? Okay.
Yeah.
All right. Your R is your interest rate as a decimal. And what do you think T is? T is always time. So memorize this little formula, A per.
What is the A mean?
Your amount. The amount you have. So this is compounded continuously. That means the interest rate continues to go. It doesn't compound daily or weekly or monthly. It's just constantly compounding the interest. All right. So we're going to do a little word problem. You don't have to write the word problem, but I'm going to. You deposit. I should have already had it in here, but I didn't. $1,000 in an account. I should type it. That pays 6% annual interest. Compounded continuously. What is the balance after 1 year? The balance means how much money you have in your account after 1 year. So we're going to use the formula A per. So we're going to fill in what we know. We're looking for A, which is the amount. Balance means the amount in your account, right? That's your balance. That's how much you have. So A is going to equal 4,000 is my principal. That's how much I put in. E is just a number. And I'm raising it to, what's my rate?
6%.
6% as a decimal is what?
0.06.
0.06. And how much time is it in there?
For 1 year.
For 1 year. So my time is 1. Okay? Now, first thing I want to do is multiply these two exponents together. What's 0.06 times 1? No, that's adding. Yeah. It's just 0.06, right? And to get that amount, we can type it straight in our calculator. So you just put it straight in like it does it. Go to second, quit to get back to your home screen. And then so you can type it in because your calculator will automatically do the order of operations. So hit 4,000. And then E, which is second LN, and then 0.06. Close your parentheses. Hit enter. Now, y'all, common sense tells us that if we're doing interest rate on money, the answer should be higher than what you had to start with, right? We know we should have more than $4,000 in there, right? Yeah. If I'm talking about gaining interest. So this is dollars and cents, correct? So A is approximately, put dollar signs on it. And we have how many decimal places when we talk about money? 2. So $4,247 and how many cents?
35 cents. That's what
35 cents. So $4,247.35. So I gained $247.35 after 1 year.
You really gained them $247.
And 35 cents. Yeah. That's just 1 year. Okay. So there's that problem. All right. So I want y'all to look with me at number 10 in your book. Open your book, y'all, because this is another word problem, and I don't want to write, and I don't want to make y'all to write. If y'all need a book, come get it real quick. Everybody get out. You need one?
I got one. Thank you.
All right. Look on page 495. Page 495. We're going to do some calculating. Page 495, look at number 10, where it says guided practice. All right, it says you deposit $2,500 in an account that pays 5% annual interest compounded continuously. Find the balance after each amount of time. So we're going to find it after 2 years, and then after 5 years, and then after 7.5 years. Y'all see that on number 10? Okay, so let's first do the formula. A equals P e to the RT power. What's my principal amount here?
2,500.
2,500.
At 5%.
And it's 5%, which is 0.05 to the T, or times T, right? So the first one is for 2 years, correct?
Yes, ma'am.
So let's type that straight in our calculator and tell me how much you think we're going to have after 2 years. First of all, we got to multiply those first, don't we?
0.1.
Okay. So point E, oops, I didn't hit my second. E to the 0.1. So yeah, you have to multiply those exponents first, and that's going to be 0.1. And then hit enter. And 93 cents.
So we gained 200 and.
So 2,700. Mine won't let me keep. I wish it'd let me keep both of them at the same time. 62.93. So after 2 years,
You gained $212.93.
very good. So then we're going to try it again for after, what did it say? 5 years? So 0.05 times 5. So first, y'all, we're going to do 0.05 times 5. 0.25. So we're going to say 2,500 times E raised to the 0.25 power.
You get
Whoopsie.
$3,210.06.
I believe you. I'm just, my thing hit a button. $3,210.06. Did y'all get that?
So that would be.
And make sure when you're writing about money, you put your little dollar signs and your decimals. And that's important. Yeah.
$710.06 we gained.
Good job. And then what's the last one they wanted me to try? After how many years? 7.5. So it's 0.05 times 7.5. So when you do that first, 0.05 times 7.5. Oopsie. This is real life stuff, isn't it? This is good math. 0.375. So 2,500 times E to 0.375.
$3,637.48.
Very good.
We gained $1,000, $1,137.
So not bad if you have $2,500. You can stick away for 7.5 years, right? The problem is, though, finding good accounts to store your money in. Because they just aren't there when the stock market's not there. Hang on, we're recording. All right, so any questions on anything we've covered today? APERT's not hard, is it? It's really not. So we're going to stop for today. Have a good afternoon.